address, and I thank all the organizers for giving me an opportunity to welcome all the delegates and dignitaries. Thank you.
Thank you so much, sir, for welcoming the dignitaries and participants, and also a briefing about the webinar. Now it's a time for inaugural address. I request Honorable Vice Chancellor of UAS Raichur, Dr. K.N. Kattimani, sir, to address the participants of this webinar. Sir, please.
Thank you, Dr. Matar. Good morning to all. I am very happy. We are conducting a webinar on role of nanotechnology in food and agriculture in the College of Agriculture Engineering, University of Agriculture Sciences, Raichur. This Center of Nanotechnology was established in the University of Agriculture Sciences during the year 2012-13 under Rashtriya Krishi Vikas Yojana RKVY, Government of Karnataka. The center was well established and physical, chemical and biological synthesis laboratories in this university, and some good work is going on in this university on nanotechnology wing. I am very happy. Already the University of Agriculture Sciences Raichur, some of the key officers of the university, they are participating in this webinar. Dr. M.G. Patil, Director of Education, Dr. B.K. Desai, Director of Research, and Dr. B.M. Chitapur, Director of Extension, and Dr. Veeran Gowda, Dean Agri Engineering, College of Agriculture Engineering, Raichur, and Organizing Secretary Dr. Sharan Gowda, and Co-Organizing Secretary Dr. Uday Kumar Nidoni, Department of Processing and Food Technology, College of Agriculture Engineering, Raichur, and all the lead speakers, participants, students, faculty, and lead speakers. Already Dr. Sharan Gowda, he has expressed the gender-wise, 50% of male and 50% of female, 44% of female, because nanotechnology, I think they are attracting more to the female candidates. Anyway, more than 1,000 participants, they have registered this seminar. I am very happy, and I know some of the speakers. Dr. V.V. Nargund, he is going to talk about the nanotechnology in plant pathology, and Dr. Prem Santi, and some important Dr. Deepa Bhagat, Dr. Mohan C. and Dilip Rauf, and I know some important personalities, those who are participating to make this webinar a very excellent manner. And whatever we are going to do the research related to any field of specialization, it should have an impact on farming community. That is very important. Whatever we are doing in the lab, it should be go to the land. So the important thing is whatever we are going to do the research in lab, it should be go to the farmer's field. Then this wing, this nanotechnology, in agriculture nanotechnology, it is more emphasized given to the lab conditions. So this center was very earlier, 2012 to 2013, 12-13 to till today, more than 4 different patents they have made, from this nanotechnology department, and more than 40 publications they have published in the renowned journals. And I'm very happy. The work is going on efficiently, but because of the manpower, that is the more constraint in our university. Because the government of Karnataka, they have given very meager amount to carry out the work in education, extension, as well as research. In this way, anyway, they are having more ad hoc projects to run the nanotechnology department in efficient manner. And also, I am requesting all the scientists, those who are working in the nanotechnology wing, they should write ad hoc projects and strengthen the department, nanotechnology department in University of Agricultural Sciences, Raichur. And some of the industrialists are there. If they are interested to provide some of the projects to this university, some of the international scientists, some of the international renowned speakers, kindly deliver the speech which will helpful to the farming community, as well as give the strength to strengthen the wing of nanotechnology of at UAS Raichur. I am very happy in agriculture. Nanotechnology is an employ to increase food production with equivalent or even higher nutritional value, quality and safety. Efficient use of fertilizer, pesticides, herbicides and plant growth factors, regulators are the most important way to improve the crop production. This nanotechnology is one of the most important tools in modern agriculture, and agri-food nanotechnology is expected to become a diverting economic force in the near future. Agri-food themes focus the sustainability and protection of agriculturally produced foods, including crop of human consumption in and animal feeding. Nanotechnology provides a new agrochemicals agents, a new delivery mechanism to improve the crop productivity, and its promises to reduce the pesticides use. This nanotechnology can boost the agriculture production as its application includes, first one is nano information formulations of agrochemicals for applying pesticides and fertilizer for crop improvement. The second one is the application of nanosensors and nanobiosensors in crop protection for identification of disease and residues of the agrochemicals. Third one is nano devices for the genetic manipulation of plants. And fourth is the plant disease diagnostic. And fifth one is the animal health, animal breeding, poultry production. And sixth one is post-harvest management. Even the precision farming techniques could be used for further improve the crop yield, but not damage soil and water, reduce nitrogen loss due to leaching and emissions. In this way, this nanotechnology is having a maximum help in the agriculture and food safety. The rapid development of nanotechnology has been facilitating the transformation of traditional food and agriculture sectors, particularly in the invention of smart and active packaging, nanosensors, nanopesticides, and nanofertilizers, etc. Numerous novel nanomaterials have been developed for improving the food quality and safety, crop growth, and monitoring the environmental conditions. In this way, this wing is having a more potentiality, and whatever research has been done so far in this particular wing, it is not it has not occupied a maximum potentiality in this world. Therefore, whatever work we have done, it is a meager work we have done. It is scanty and scattered. So, this wing should be do some important activities. And this webinar is also having interaction with upcoming strategies in field of nanotechnology with the scientific community. The conceptual and pertinent knowledge shared will be correspondingly foster organizational collaboration to nurture the scientific acceleration. This webinar designed to encourage the exchange of ideas across the broad range of disciplines. This webinar will be explore a new possibilities and immense ourselves in the outstanding community for professionals dedicated to improve the nanotechnology and nanosciences. The center already I have expressed the center has given a very good impressive work in this field. I congratulate the persons, those who are working in a nanotechnology wing. And again, I will force them to bring the ad hoc projects from the other financing agencies to strengthen the nanotechnology wing, as well as the participants and some of the industrialists are there. If they are providing any financial assistance to hasten the activity of the nanotechnology, I am very happy. And I once again welcome and express my sincere thanks to all the participants and lead speakers to provide the recent innovation information to the farming community and industries and participants for adopting this nanotechnology in food and agriculture effectively. With these few words, I congratulate all the organizers who involved in this webinar, and I express my sincere thanks to provide who provided me an opportunity to inaugurate this webinar on role of nanotechnology in food and agriculture. Thank you, one and all.
Thank you very much, sir. Thank you, sir. Thank you. Thank you, sir, for appreciating the works of nanotechnology and also emphasizing on research should go to the farmers field, and also briefing about the important applications of nanotechnology in different fields of agriculture. I once again thank you, sir. Now it's a time to hear the words of our distinguished guest of honor, Dr. B.K. Desai, sir, Director of Research, US Raichur. I request Dr. Desai, sir, to address the participants of this webinar.
Thank
Desai,
you.
sir.
Thank you. Good morning, everybody. It gives me immense pleasure to be with all of you. Even though we are not directly physically present, we are present through the modern technology, that is through almost all the ICTs. So here, just at the outset, I would like to join hands with our Honorable Vice Chancellor to congratulate the organizers, co-organizers, that is Sharan Gowda, Veeran Gowda, and Nidonia and his team, to organize such a event, that is webinar, that too for 10 days. So it's not a joke to organize this. So bringing all the scientists together in one platform and requesting them to give lecture in their expertise, that too on this new emerging technology, that is nanotechnology. So our university, as our Honorable Vice Chancellor mentioned, started its research on nanotechnology with the inception of the project on nanotechnology that was sponsored by Rashtriya Krishi Vikas Yojana during 2012-13. So after that, it didn't look back. So we can say that we are still in its infancy. That is the application right away. It should go to the field, as our Honorable Vice Chancellor mentioned. So whatever the technology that has been there, evolved in our institute, in our center, so that has to be brought to the farmers' fields, no doubt. But even then, we can congratulate the scientists for having patented. They have obtained around 3 to 4 patents as well for their products that are developed in our institute. So that's also a credit it brings to the US, that is University of Agricultural Sciences, Raichur. So as I am not an expert in this particular field, even just I can throw light on the what research has to be done in this particular field, as far as my knowledge is concerned. So when we look back to the Indian agriculture, so which started right in 1950s, so we are here in 2020. So with the increased food production, no doubt. So we are self-sustaining in our food production. But even then, a lot of concerns are being expressed. So what to increase the food production, whatever the technologies that we have followed, that what we call as modern agriculture. So no doubt it has increased the food production, but along with it has degraded the resource base. So that means to say, indiscriminate usage of all the chemicals, of all the resources, of all the natural resources, over exploitation of natural resources has brought the challenges to the sustainability. So when we say the challenges to the sustainability are at stake, that means to say we have to have an alternative to preserve the human health, to preserve the nature, as well as for healthy life. So our lifestyle should be very healthy. So here comes to our rescue, that is for sustainable agriculture, which is no doubt on innovative techniques that are being evolved by various scientists. They are evolving, and one of them is nanotechnology. Naturally, it haunts to our mind that what is this important technology? Let us all know this technology. That means to say, as Shangoda mentioned, so plenty of room at the bottom. That means to say, this was said in the year 1959 by Feynman's lecture. So in that lecture, he has mentioned the sentence, plenty of room at the bottom. So from this very day, the process of nano process, it is in underway, we can say. Later on, the Professor Nario Taniguchi, he proposed the actual term nanotechnology. So afterwards, it developed in a vivid way, we can say. That means to say, it is well known that 1/1000th of a meter is 1 nanometer. So why this nano will change its property? Mainly because the alteration is there in the atoms and develops a magnetic power. That means to say, it can be projected that smaller the size of nanomaterial, it possesses larger the surface area and exhibits more activeness. So that principle is adopted here. So with this course of action, the nanotechnology is knocking the doors of perception. So that means here nanotechnology has got large scope in agriculture. That means here in the amount of spread of chemicals, then minimize nutrient losses, especially in fertilization. It is a lot of scope, and increased yield through nutrient management, pest management, etc. So the application of nowadays, the application of chemically synthesized nanomaterials is considered to be toxic in nature. To attack this, already our scientists have an alternative way also. That means nanomaterials may be synthesized from plant system, and it is considered as green nanotechnology. That's what our Center of Nanotechnology in US Raichur is focusing on, green nanotechnology. So here, this green nanotechnology is a safe process, which is energy efficient as well, and reduces wastes and lessen greenhouse gas emissions. So use of this renewable materials in production of such beneficials will no doubt will be helpful and will be having less influence on the environment as well. So such of the nanomaterials that are produced are eco-friendly, we can say, and sustainable, and significant advances are to be made, yet to be made. That means to say, more research has to be done in the present decade. So there is a shift towards, when we say there is a shift towards green nano in a faster rate of implementation, still is not that much clear as to how the environmental sustainability of green nanotechnology will be achieved in future. So our scientists have to ponder, and a lot of experts are also there. So you can also interact. So there is a lot of scope here for interaction, and you can have more of the research ideas from our experts as well. And all these 10 days, as Veran has mentioned, I will be with you whenever I am free, definitely. And the development of high tech agriculture system that is nowadays required with the use of engineered smart nano tools are the present day requirement. So this could be the excellent strategy to make a revolution in all the agricultural practices. So the topic chosen, that is from the Center of Nanotechnology, that is the role of nanotechnology in food and agriculture. It's very well chosen, and it is a very right topic on the present day. So a lot of discussions, they have to do a lot of discussions, and I once again congratulate the organizers and wish for its successful completion for all the 20 days. And also I welcome all the experts from on behalf of university to share their thoughts as well. So thank you very much. Thank you for providing me an opportunity to express my views in this inaugural session. Thank you. Thank you very much.
Thank you, sir.
Thank you, sir. Exploited natural resource.
It's not clear, Matad. It's not clear. It's not audible. It's not audible.
Sorry, sir. Thank you, sir. Thank you very much. You have focused on ancient agriculture to the modern agriculture and how we have overexploited our natural resources. And now we are at the stage to focus on healthy and sustainable agriculture. And also we have emphasized on green nanosynthesis, which is very nature friendly and without any risks. So now, thank you very much, sir, once again. Now it's time to remember the contributions made to make this event a grand success. For this, I request Dr. Uday Kumar Nidoni, Professor and Head, and also the co-organizing secretary of this webinar to propose the vote of thanks. Sir, please.
Thank you, Dr. Mathad. A very good morning to all. It gives me an immense pleasure to deliver vote of thanks for this inaugural session to all the dignitaries and participants attending this webinar. First of all, on behalf of webinar organizing team and all the participants, I would like to express heartfelt thanks to our Honorable Vice Chancellor, Dr. K.N. Kattimini sir, for sparing his valuable time and for inaugurating this important 10 days webinar, and also for addressing the participants. Thank you very much, sir. Next, our sincere gratitude to our Dr. M.G. Patil sir, the Director of Education, UAS Raichur, for being part of this event. Thank you very much, sir. Our sincere thanks are also due to this session's chief guest, Dr. B.K. Desai sir, the Director of Research, UAS Raichur, for addressing the participants and for his best wishes to this webinar. Thank you very much, sir. We also express our heartfelt thanks to Dr. B.M. Chitapur sir, the Director of Extension, UAS Raichur, and all the officers of UAS Raichur for being part of this event. On behalf of UAS Raichur, I would like to express our sincere thanks to all the contributors who are going to share their expertise with other participants during this 10-day long webinar. Thank you, each of them. A special mention to our beloved Dean and co-organizing secretary, Dr. M. Virangouda sir, for being a catalyst that stimulated us to do our best. Thank you very much, sir. With deep sense of appreciation, I would like to thank the organizing secretary of this webinar, Dr. Shanagouda Hiregaudar, Associate Professor and Head of this Center for Nanotechnology, UAS Raichur, for his untiring efforts in planning and execution of this webinar. Thank you, Dr. Shanagouda Hiregaudar. I would like to express my heartfelt thanks to all the organizing coordinators of this webinar, the people who worked behind the scene to make this event. Thank you, all of them. Last but not the least, on behalf of UAS Raichur and on behalf of all the organizing team members, I would like to thank all the participants of this webinar for showing their overwhelming response and interest and also showing immediate response to our invitation. Thank you, one and all. And once again, all the participants, dignitaries participating in this webinar, thank you, one and all.
Thank you, sir. Now the technical sessions will start. I thank the organizers for giving me this opportunity to moderate this inaugural session. So the inaugural session will be coming to an end. Now the technical sessions will start. Now it's I'm handing over the mic to Dr. Sharanagowda Hiregowda. Thank you, sir.
Thank you very much, respected Honorable Vice Chancellor of the University, Dr. K.N. Kattimani, sir, and Director of Education, Dr. M.G. Patil, sir, and Director of Research, Dr. B.K. Desai, sir, and our Director of Extension, Chitapur, sir, and all the officers of the university who have joined hands for this inaugural session. And also thank you, Dr. M. Urnagoda, sir, and our Professor and Head, Dr. Uday Kumar Nirvani, sir, and also who has coordinated for this inaugural session as well as the 10 days program. So now we are going to start this technical sessions of 10 days program. So as you already aware that it has been scheduled for 10 days, and the morning session we have a lecture from the different experts starting with the processing, packaging, then water purification, then formulations, then plant pathology, entomology, like surfactants and all such kind of related to the agriculture related. We have 10 different experts who is working in the field of nanotechnologies. Those experts lectures has been scheduled in the morning session. So that session is already fixed 11 a.m. to 12:30 p.m. So almost 45 to 50 minutes or maximum 1 hour will be the lecture, and remaining 30 minutes will be the interaction session. So that was the schedule. And we have an afternoon session of different industrial experts, the specialists from the different instrumentation which they are using in the field of nanotechnologies, especially like particle size analyzer, homogenizer, scanning electron microscope, XRD, FTIR, AFM, XPS, Raman spectroscopy, like that. Even we have, to measure the toxicity like LCMS, GCMS. So like that, we have been scheduled for the different instrumentation experts from the different industry. They are going to give you a hands-on expertise, the application of these materials in the instrumentation, and how we are going to correlate through the instrumentation. That will help to the researchers as well as the students for writing the papers as well as to understand the nanotechnology. This is how the 10 days schedule has been made for starting to the today to the till end 29th of this August. And even there is no break even Saturday, Sunday also. My humble request to all the participants, please join 5 minutes early, and make sure that you should be get present, complete the day when the session is on. So why means, there are excellent experts who have done their research in the field of nanotechnologies. Don't miss the opportunity. That's why I requested all the participants to participate in this particular webinar. And also after the day completes, we are going to send a feedback link for every day. So kindly fill the feedback form and reply within an hour. So that is the schedule has been decided, and as per the guideline or as per the technical decision. So 80% of the attendance for this particular webinar is the mandatory for completion of 10 days webinar. So that's how the whole formalities has been made, and all the circulation has been done. And another important to all the participants, so we have been created one Telegram link, because WhatsApp group is not possible to add all the members. So we have created one Telegram link, and the link has been sent to all the members through the their mail ID which they have registered. Kindly join for this particular Telegram link so that we can update whatever the experts which they are going to share their even the PPTs or whatever the things, even the feedback form, all those things has been shared in the Telegram link in the coming days. So with this, we have a different experts, what I just mentioned you, expert from the USA, expert from the Italy, experts from the New Zealand. So like that, across the countries also we have, and across the state of the India, we have the experts from the different applications. So in the morning session, we have one expert from the application and overview of nanotechnology and its application. This is the first session which we are going to start in the morning session. So we have an expert like Dr. Prem Shanti Yerugupa. So he's right now in the USA. So I think she has already joined.
Yes.
Yeah. Thank you, Prem Shanti. Yeah. So may I request Dr. Rupa to introduce Dr. Prem Shanti Yerugupa for this technical session. So Dr. Rupa, please, for the introduction of a brief introduction of the Dr. Prem Shanti. Rupa, please.
Thank you very much, sir. So, welcome. Good morning to everyone. So, it gives me an immense pleasure to introduce today's first speaker, Prem Shanti, who is going to speak on an overview of nanotechnology and its applications. So, Prem Shanti, she is doing her PDF at Washington State University, USA. So Prem Shanti, she was born on 19th February 1993, and she is a native of Bapatla, Andhra Pradesh. She has completed her schooling in Bapatla. Then later, she has joined for BTech program, BTech in Agricultural Engineering from Acharya N.G. Ranga Agriculture University, Bapatla. Then later, she did her MTech in Processing and Food Engineering from University of Agriculture Sciences, Bangalore. Then later she did her PhD in Processing and Food Engineering and specialization in nanotechnology from University of Agriculture Sciences, Raichur. Then coming to her research experience, she has experience in performing the testing and evaluation on-farm mobile paddy dryer, then development of a process technology for accelerated aging of rice. And she has also an experience in studies on biological, chemical, and microbiological mediated synthesis of silver nanoparticles and its applications. She has several publications in various research. And then she has many awards, as well as she has achieved many things in a short period. That is, she has received a senior research fellow for her for her doctoral degree, and she has secured a third rank in that. Then she has received four gold medals for her highest OGPA in master's degree, as well as one gold medal for topping the university among all the master degree students. Then received the best poster award at KSDA National Conference. Then she has also been qualified for ICR NET. Now presently she is doing a postdoctoral fellow at Washington State University. So with this brief introduction, I welcome Prem Shanti to give a lecture on or to speak on an overview of nanotechnology and its application.
Thank you so much, Dr. Rupa, for the brief introduction of the Dr. Prem Shanti. So now I request Dr. Prem Shanti for this session. Prem Shanti, please.
Thank you so much, Rupa ma'am. I feel privileged to start the first lecture of this webinar session. And I thank all the dignitaries of the university and organizing secretary, Dr. Sharangauda sir, and the co-organizing secretary, Dr. Uday Kumar Nidoni sir, and Dr. Virangauda sir for giving me this opportunity. I think I can start the presentation, sir.
Yeah, you can share.
Yes, sir. Good morning, everyone. I welcome you all for this webinar on role of nanotechnology in food and agriculture. I was given the topic of to speak on an overview of nanotechnology and its applications. And in this presentation, I'm going to cover all these topics like introduction of nanotechnology, the history and timeline of nanotechnology, and different nanostructures that are available in the nature, and synthesis of nanoparticles and what are the different methods of synthesis of nanoparticles and the characterization of nanoparticles, the applications of nanoparticles in different agriculture and food and also in various fields, and what are the challenges that are taken up by nanotechnology and the future prospects of nanotechnology, conclusion of the seminar and references I have used. As we all know that nanotechnology is a science, engineering and technology which deals at the nanoscale, and it is the study and control of phenomena and materials at nanoscale, which is about 0.1 to 100 nanometers. That is 1 nanometer is 1 billionth of a meter, that is 10 power minus 9 meter. And in a comparable scale, 1 nanometer is almost 1 by 5 millionth size of an ant. And also it is 1 by 100,000 to the diameter of an human hair. So that small it is. And it is also 1 by 90th size of an HIV virus. To compare, in a regular sense, our fingernail grows 1 nanometer every second, which is impossible to see with a naked eye. And coming to the important definition of nanotechnology, it is the art and science of manipulating and rearranging individual atoms and molecules to create useful materials, devices, and systems. The different properties of nanoparticles, as we have seen, it is having a large surface area. So the different properties such as chemical, optical, mechanical, and magnetic properties of nanoparticles are because of these increased surface area, which are than compared to bulk materials. And we'll understand more about the nanotechnology by seeing this video.
What exactly is nanotechnology? To answer that question, first we need to think small. Really, really small. Smaller than anything you've ever seen through a microscope in school. Think atoms and molecules, and now you're looking at things on the nanoscale, where scientists are developing exciting new materials that can range in size from 1 to 100 nanometers. But how big is a nanometer really? Let's take a closer look at something we're a bit more familiar with, like hair. 1 nanometer is 100,000 times smaller than the width of a single human hair. So we're talking really, really small. But just because these nanomaterials are small, doesn't mean they're insignificant. Because they're so small, they have some amazing abilities. Some have different magnetic properties, some are better at conducting electricity or heat, and some can actually change colors depending on their size or shape. Today, many of our nation's most creative scientists and engineers are finding new ways to use nanotechnology to improve the world we live in. Nanomaterials can be used in medical devices to detect diseases and in drugs to treat them, in food safety and low-cost water filters. They can be used to make smaller, faster electronics, or lighter but stronger materials for building things like bridges. They can help clean up hazardous chemicals in the environment, and they can even be used in things like textiles. With all of these amazing applications for nanomaterials, just imagine where nanotechnology might be able to take us in the future.
And the shapes, there are different shapes and forms of nanoparticles, like they are available in uniform shaped or also in irregular shaped, and they are dispersed particles, and some of the nanoparticles are in agglomerated form, and they are in free and bound form also. And the ideas and concepts behind this nanoscience and technology started with a talk entitled "There is a Plenty of Room at the Bottom" by physicist Richard Feynman at the American Physical Society meeting conducted at California Institute of Technology on 29th December 1959. This meeting was held long before the time nanotechnology was known. In this talk, Feynman described a process in which scientists would be able to manipulate and control individual atoms and molecules. So not before that, there was no talk was conducted on this topic, like on atomic scale. Over a decade later, in his explorations of ultra-precision machining, Professor Norio Taniguchi of Tokyo University, he coined the term nanotechnology in the year 1974. As the modern nanosensor technology is quite new to us, but it is started long back in 4th century. The Lycurgus cup in Rome is an example of diachronic glass. The different colloids of gold and silver used in making of this glass, it looks opaque, like it looks opaque green when light hit from the outside, and it looks this translucent red when light shines from the inside. This cup is still kept in the British Museum. And later on in 15th century, vibrant stained glass windows, similar like gold and silver nanoparticles are used in not nanoparticles, gold and silver particles, which are very small, are used in making of glass windows in European cathedrals. They have observed that there are different colors emitting from those windows. So by that time they were not knowing the concept of nanotechnology. And later on, in the year 1959, the talk conducted by Richard Feynman was considered as the first talk on atomic scale. And later on in the year 1974, Taniguchi uses the term nanotechnology for the first time. And in the year 1981, G. Binning and H. Rohrer at IBM Research Lab, they developed scanning tunneling microscope to see individual atoms for the first time. And these both has awarded Nobel Prize for their discovery in the year 1986. And in the year 1985, Rice University researchers Richard Smalley and his team, they discovered Buckminster fullerene, more commonly known as buckyball, which is containing carbon atoms in all its sides. Buckyball of molecular formula C60, which is a molecule resembling a saucer ball and composed entirely of carbon. The team was awarded Nobel Prize in the year 1996 in the field of chemistry. And later on in the year 1986, Engines of Creation, which was the first book on nanotechnology.
Sorry to interrupt, Dr. Prem Shanti. So there is a problem with your screen, I believe, because we're getting a blur. So can you close the share and share it again, if you don't mind?
Sure, sir. Sure, sir.
Yeah, stop screen sharing, then go for again. Yeah.
Sure, sir. Is it okay, sir? No?
No, feeling still it's blur only.
Just give me a minute, sir. Just give me a minute.
Yeah, please. No, sometimes it will be clear and sometimes it will be blur. Yeah, you can do it once again, stop sharing and you can do it. But
Sure.
it will be clear. Yeah. Yeah, it's good. It's fantastic.
Thank you, sir.
Yeah.
And in the year 1986, the first book on nanotechnology was published by K. Eric Drexler on the title Engines of Creation. And in the same year, G. Binning invented atomic force microscope to view nano-sized materials. And in the year 1989, Don Igler and Erward Schweizer made IBM logo at IBM Research Center by using 35 individual xenon atoms to spell out the IBM logo, which is just like this, which is the applied use of nanotechnology. And in the year 1991, carbon nanotube was discovered by Sumino Izima, which is the tubular shape of a buckyball. And she received Kavli Prize in Nanoscience in 2008 for this invention. And in the year 1999, Nanomedicine, the first nanomedicine book was launched by R. Freitas with the title Nanomedicine. And in the year 2000, the National Nanotechnology Initiative was launched by President Bill Clinton in US. And coming to nanotechnology in India, in ancient India, Damascus steel or wood steel was developed in India somewhere between 2200 BC and 300 AD. Wood steel was made with a mixture of a large quantity of carbon and iron, and this same composition was used in making swords at that time. And in the year 2009, Professor Chintamani Nagesa Ramachandra Rao, who is born in Bangalore, Karnataka, he launched the India's first magazine on nanotechnology with the title Nano Digest. It is the first premier magazine on nanotechnology, and he was called as a father of Indian nanotechnology. And coming to the green nanotechnology, Dr. Katesh V. Katti, he synthesized, before the nanoparticles were synthesized using chemical method, but he first introduced green technology to synthesize nanoparticles. He used green tea leaves to synthesize gold nanoparticles, which have been used in curing cancerous cells. And we will listen more about his research from his own words.
I am Keteshvi Kadi, Curator's Distinguished Professor of Radiology and Physics. I am interested in coming up with or discovering new approaches for cancer detection and cancer therapy. We have many unanswered questions. That's why we see thousands and thousands of patients die every year. My challenge has been to come up with new technologies to see if I can make a difference in the lives of these cancer patients. Many of the cancer drugs are very toxic. They're toxic to tumor cells, which is important, but they're also toxic to normal cells, which is not good. That creates toxic side effects to the body. We discover nanoparticles of gold, for example, and then make them cancer specific. We encapsulate these nanoparticles with certain chemicals. These are chemicals that are already there within the human food chain. That basically makes our approach so much different compared to other approaches. Our approach encapsulates these phytochemicals on nanoparticles. We are not trying to inject or have patients ingest toxic chemicals. Once in the body, this phytochemical defines the direction for these gold nanoparticles to go and localize around the tumor cells and perhaps get these particles into the tumor cells to reduce the growth of tumor cells and also destroy those tumor cells which are already there in the body. This approach of treatment in cancer therapy actually improves the ability of the body to fight the disease. Our objective is not just to discover, our objective is not just to develop a new scientific knowledge and publish it and patent it and perhaps win awards. That happens all the time. We clearly want to make a transformative difference in the lives of human patients.
That's about Dr. Keteshvi Kadi. He is born in Dharwad, Karnataka, and he is now at University of Missouri Medical School professor. He is working there since 1990, and he was called father of green nanotechnology by Norman Borlaug. And it is good to know that the father of Indian nanotechnology and father of green nanotechnology both are from Karnataka. And the major goals of green nanotechnology are producing the nanomaterials without harming the human health, and also producing the nano product that provides solution to many of the environment problems. And coming to the nanoscale, this determines the nano range, like from 0.1 to 100 nanometers, it is considered as nano world, and from 1 micrometer to 100 micrometer, it is micro world. So when comparing the nano scale with the natural the human hair is around 80 to 100 micrometer width, which is 100,000 times more than 1 nanometer, and the diameter of ant is 5. Width of ant is 5 mm, and the red blood cell diameter is 2 to 7 micrometers, and antibodies in NTP synthesis is around 10 nanometer, and DNA in human body is around 2 to 0.5 nanometer in diameter. And coming to the things man-made, the head of a pin is around 1 to 2 mm, and the many micro-electromechanical devices are 10 to 100 mm in width, and the carbon nanotube width is 1 to 2 nanometer. And we will see more about this in this video. nanoscale, the diameter of this coronavirus, which is affecting the whole world, is around 60 to 120 nanometer. So that small the nano is. And coming to the nanostructures in nature, before the invention of nanotechnology, the nanostructures have been in the nature. The major example for these nanostructures are lotus. The lotus, which is having botanical name of Nelumbo nucifera, it is having a hydrophobic surface on its leaves and flowers, and they are the water repellent surfaces. And because they are formed by 10 to 20 nanometer sized wax papillae on the upper side, and if some water or some rain drops on its surface, it makes a high contact angle with the leaf, and it drops off carrying the any accumulated dust or dirt, which gives a self-cleaning property for the lotus leaves. So that property of lotus is called as lotus effect. And this technology many scientists have been trying to implement in our inventions. This is about the lotus effect.
The aim of this video is to demonstrate and explain the hydrophobic nature of a surface. The experiment was conducted on a hydrophobic leaf. As you can see, when a steady flow of water is directed towards the leaf, no water droplets stick or wet the surface of the leaf. Due to this, the surface remains dry and clean at all times. This is an example demonstrating lotus effect. Here is a slow motion clip showing how the liquid just bounces and rolls off the surface. Now we repeat the experiment using a more viscous liquid. In our case, we used honey. The same is true for honey also. It trickles down the surface of the leaf without staining the surface. So why does this happen? We can explain this by two concepts, which are the surface structure and the contact angle. If we take a closer look at the surface structure, it shows that it is not smooth at all as it seems. This is due to the presence of some micro protrusions that are coated by nanohydrophobic solid materials. This combination will give a rough surface that has perfect water repellent properties as it was shown in the video. This will also give the surface a self-cleaning property, in which the dirt particles tend to stick to the water molecule as it rolls off the surface. Such a surface would have a high contact angle with the liquid droplet. This is because of the low surface energy of the leaf, leading to a sphere formation of the water droplets, which minimizes the area of contact between the leaf and the water droplet and will eventually result in a high contact angle. Lotus effect can be explained mathematically by taking into account the solid fraction, air trap fraction, roughness, and the contact angle measured by Young equation on a flat surface. The equation shows that if the solid fraction approaches 0, the contact angle described by Casey and Baxter will approach 180 degrees, which is hydrophobic. Understanding the science behind this phenomenon gives rise to many practical applications in the chemical industry. It is our role as engineers to enhance the applications in more than one way. Thank you for being.
And coming to the other nanostructures in nature, one more example is moth's eye. The moth eye is having very small bumps on its surface, which are of hexagonal shape. They are in the nano size. These patterns are smaller than the wavelength of the visible light. So it has the low reflectance and high absorbance for the visible light. So the moth can see better in dim and dark conditions than the human eye. And coming to the butterfly, one of the major example is the wing of male morphoretinor. It has multiple nanoscale pattern on wings, which filters the light and reflects only one wavelength. So because of that, we are able to see the bright blue color of the butterfly. And many scientific instruments use same phenomena to analyze the color of light. And coming to Edelweiss, these flowers are covered with thin hollow filament that have nanostructure on their periphery. And these nanostructure are same as the size of the visible light. So it absorbs all of the UV light and reflects only visible light. This explains the white color of the flowers. And it also protects the flowers from damage because of its high radiation. And coming to the nanoscale approach, there are two approaches in nanoscale. One is top-down approach and other is bottom-up approach. Top-down approach is creating nanoscale material by physically or chemically breaking down the larger particles. Like from here you can see from the bulk material, the nanoparticles have been cut down to, the particles have been cut down to nano size. And coming to the bottom-up approach, assembling the individual atoms and molecules to form a nano size. And the examples of top-down approach are milling, cutting, and grinding. And the biological synthesis or green synthesis comes under bottom-up approach. And the size of the nanostructures are between 10 to 100 nanometer in top-down approach, and less than 10 nanometer can be possible in bottom-up approach. And in top-down approach, it introduces internal stress and surface defects and contaminations can be possible in top-down approach, as it involves so much of energy and pressure. And in bottom-up approach, it has less defects and more homogeneous mixture can be available from bottom-up approach, and it is more advantageous over top-down. And coming to different types of synthesis of nanoparticles, there are 3 methods of synthesis of nanoparticles, which are chemical method, physical method, and biological method. Under chemical method, there are 2 methods. One is chemical reduction and solvothermal synthesis. Under physical, there are two methods, ball milling and microwave synthesis. Under biological, the synthesis of nanoparticles can be takes place either by plant and their extracts, and also by microorganisms like bacteria, fungi, and yeast. And coming to the first method, chemical reduction, which is the simplest and most commonly used method for bulk solution. And it involves the reduction of a metal precursor in the presence of a surfactant using a reducing agent. Surfactant mainly means it has the important role to stabilize the particle growth. Like by using surfactant, we get the uniform sized particle, and it protects from sedimentation and agglomeration. Using chemical reduction method for synthesis of different morphologies of nanoparticles can be obtained by using chemical reduction. Main components of chemical reduction are metal precursor, reducing agent, and stabilizing agent. And this is chemical synthesis of silver nanoparticles using trisodium citrate. This has been a part of my PhD research. I have taken trisodium citrate and as a metal precursor, and silver nitrate as a reducing agent. Here I have used heating and stirring method in place of stabilizing agent. So silver nitrate solution and trisodium citrate solution have been prepared. 100 ml of silver nitrate solution has brought to boiling point, and after that 12.5 ml of trisodium citrate solution added, and after that the color changes from transparent to pale yellow, which indicates the formation of silver nanoparticles. And proper stirring for about 30 minutes gives the uniform size nanoparticles. So we get chemical synthesis silver nanoparticles. I have seen someone raising the hand. Do you have any questions? Can I go? Can I continue, sir, or?
Yeah, you can continue.
Oh, okay. Okay, coming to the second method in chemical synthesis is solvothermal synthesis. A chemical reaction in a closed system in the presence of solvent at a temperature higher than the boiling point of solvent. So this method is mainly used for the unstable particles, like the particles which are very unstable near the melting point. For such kind of particles, we can use solvothermal synthesis, and in this way, we can use high pressure around 1 to 10,000 atmosphere pressure and temperature around 100 to 1000 degrees centigrade. If water is used as a solvent, the method is called hydrothermal synthesis. And if water is used, it is performed below the supercritical temperature of water, and the critical points of water, as we all know, it is 374 degrees centigrade and 217.7 atmospheric pressure. And the main parameters of solvothermal synthesis are initial pH of the medium, the time of the synthesis, temperature maintained, and the pressure in the system. So these two are the important methods in chemical synthesis. And coming to the physical synthesis, one is ball milling. It is a physical reduction, like by using balls, the size of the particles have been reduced. This process is used in producing metallic and ceramic nanomaterials. The ball rotates around a horizontal axis. There is a cylindrical cylinder type of hollow cylinder. In that, balls are being introduced. The ball rotates around a horizontal axis partially filled with material to be ground. So the ratio of ball to material is 2:1. So 2 parts of the balls and 1 part of the material. So the material is forced to the walls and pressed against the walls. So this is the example of top-down approach. So we are reducing the size of the particle. And the factors affecting ball milling synthesis are milling container, the size of the container, how much is the size, and milling speed and milling time, and ball to material ratio, and temperature of milling maintained. And coming to the microwave synthesis, which is one of physical method of synthesis. Microwave synthesis is very new and interesting technique for the synthesis of oxide nanoparticle, like zinc oxide nanoparticle. Such kind of nanoparticle microwave synthesis have been used. And as we all know, it is having a frequency range of 300 megahertz to 300 gigahertz. And here the precursor solution have been taken, and it is stirred on a magnetic stirrer for 10 minutes to get a clear solution. And then it is kept in a microwave for 10 minutes. The water has been evaporated and white precipitation is collected. So the precipitate is repeatedly washed with ethanol and dried in a hot air oven to get a powder form of powder form which is in nano size. And coming to the biological method of synthesis, which is the green method of synthesis. Here we are using green synthesis of nanoparticles using plant extracts. Green synthesis provide advancement over physical and chemical method of synthesis, as it is very cost effective and environmental friendly, and there is no need to use toxic chemicals, and no need to use high pressure and energy. The primary and secondary metabolites present in the plant and plant extract used as reducing and stabilizing agents, and are constantly involved in the redox reaction to synthesize eco-friendly nano-sized particles. And it is the cost of production is low, and we can get the nanoparticles in a very short time, and it is safer to the environment also. And factors affecting the biosynthesis, there are several factors that are affecting the biosynthesis of nanoparticles. The one of the major important factor is pH. It influences the size and texture of the synthesized nanoparticle, and therefore nanoparticle can be controlled by altering the pH of the solution. Like the size of the nanoparticle can be controlled by changing the different pHs of the solution. And coming to the next parameter, which is temperature. Temperature is one of the most important in any synthesis, either it is physical, chemical, or biological synthesis. But physical synthesis usually operates at higher temperature, more than 350 degrees centigrade, and chemical is around less than 350 degrees centigrade. And green technology is usually takes place under less than 100 degrees centigrade or at ambient conditions also. And the temperature used determines the nature of the nanoparticle produced. And coming to the pressure, pressure is also the one of the important factor, and it affects the shape and size of the synthesized nanoparticle. The rate of reaction of metal ions using biological agents has been found to be much faster at ambient pressure. Like when we synthesize the particle at ambient pressure, the rate of reduction found is much higher. And coming to the time, the quality and type of nanoparticles synthesized using green technology are greatly influenced by length of the time for which the reaction medium is incubated. Like with the increase in the incubation time, there may be agglomeration of the nanoparticles or maybe reduction of the nanoparticles. And environment, the surrounding environment plays an important role in determining the nature of the synthesized nanoparticle. And sometimes the components in the reaction may react with the components in the environment, like either oxidation or reduction may happen. And so environment plays a major role in synthesis. And coming to the other factors involves type of plants used. There are different types of plant, and plant extract can be used for synthesis of different nanoparticles, which we will further slides. And the part of the plant, which part of the plant we are using for synthesis. Either maybe leaves can be used, the roots of the parts can be used, flowers can be used, fruits can be used, and also honey and starch can be used for green synthesis. And also different microorganisms such as bacteria, fungi, yeast, and algae, and microbial enzymes can be used for green synthesis. So these are all the factors which affects the synthesis of the nanoparticles, which means the size, shape, and morphology are going to vary based on all these factors. And coming to these are the different plant extracts that plants and plant extract have been used for different nanoparticles, like neem leaves, aloe vera leaves, barbados, zambal, okra, rose petals, oat leaves, and curry leaves. And by using all these leaves, we can get a wide range of nanoparticle size, which are usually less than 100 nanometer. And this is biosynthesis of silver nanoparticles using curry leaves. This is also a part of my PhD research. I have taken curry leaves because they are high in carbozols and terpenoids, and are having potent antioxidants, which are having heterocyclic compounds, and it helps in the reduction of metal nanoparticles in a less size compared to other plant extracts. So 10 gram of curry leaf have been mixed in 75 ml of distilled water, and I've kept in the boiling mixture using water bath, and collected the leaf extract. And 5 ml of leaf broth have added to 100 ml of AgNO3 solution, and kept on rectangular hot plate until the color changes from transparent yellow to dark brown, which indicates the formation of silver nanoparticles. And have adjusted the pH to get the proper size of nanoparticle, and we get biologically synthesized silver nanoparticles from curry leaves. And coming to biosynthesis of gold nanoparticles from rose petals, there are many plant extracts we can get gold nanoparticles, like we can get from cow urine, rose petals, like in green tea, cinnamon, many things we can get. And here is one of the example I have taken is rose petals. 5 gram of rose petals have been added to 200 ml of 80% ethanol, which has been warmed up to 60 degree over a steam bath, and it is sonicated at 50 degrees centigrade for 30 minutes, and then it is filtered. The filtered rose extract from that 100 ml is added to 100 ml of distilled water, and again it is again heated at 60 degrees centigrade. To that solution, 25 ml of chloroauric acid, which is HAUCl4 of 25 ml is added. Then the solution turns to wine red color, which indicates the formation of gold nanoparticles. And coming to the platinum nanoparticles, it is extracted from weed Lantana camera. And 2 gram of washed fresh leaves of this weed is taken and added to 100 ml of distilled water, and it is kept for boiling for about 2 minutes. And after that, addition of hexachloroplatinic acid into the solution, and the solution is being centrifuged for 12,000 rpm for 15 minutes. And after that, ascorbic acid is added to the mixture and heated at 95 degrees centigrade for 8 minutes. The solution turns from green to black color, which indicates the formation of platinum nanoparticles. And coming to synthesis of nanoparticles using microorganisms, microorganisms provide diverse environment for biosynthesis of biosynthesis of nanoparticles. Many organisms have the ability to utilize metal reduction, like in which the reduction of metal ion is coupled with oxidation of an enzyme. And in microorganisms, using microorganism for synthesis, there are two methods. Either it is intracellular and extracellular. Extracellular method consists of transporting ion to inside the microbial cell to form nanoparticles, which is happen in the presence of enzymes. And extracellular is trapping the metal ion on the surface of the cell and then reducing the ions in the presence of enzymes. One is intracellular, which is transporting inside, and the other is extracellular, which is trapping on the cell and then reducing in the presence of enzymes. So coming to different organisms used for different nanoparticles, like yeast, it is Candida glabrata, and bacteria like lactic acid bacteria, Escherichia coli, and fungal Fusarium solani and Fusarium oxysporum for different nanoparticles at to get the different sizes of nanoparticles. And here it is microbiological sense of silver nanoparticles using E. coli. It is also been a part of my research. I have taken E. coli. I have inoculated the E. coli in the nutrient broth mixture, then incubated using orbital shaker at 12,000 rpm for about 24 hours. Then we get E. coli culture, and it is centrifuged at 12,000 rpm for 10 minutes to get culture supernatant. The precipitate has been discarded and supernatant has been taken, and the supernatant is added to, like 10 ml of supernatant added to 40 ml of AgNO3 solution, and it is placed in a UV cabinet. Sorry. It is placed in a UV cabinet, and it has to be placed for the time until the color changes from yellow to dark brown. And after that, the pH has been adjusted and we get microbiologically synthesized silver nanoparticles. And after synthesis of nanoparticles, by visual observation, we can know that there is a formation of nanoparticle. But once we until we characterize the size, shape, and morphology of the particle, we never know like what size it is. It can look the same, even the particle is of more size also. So for knowing the particle size distribution, Zetara sizer have been used all over the world. And it is based upon the principle of dynamic light scattering. In this, the principle of DLS is that the fine particles like atoms and molecules are in a random motion, which is called Brownian motion, and which diffuse at a speed related to their size. Like if the size of the particle is very small, they diffuse faster than the particles are having larger size. So by after diffusing, we get a particle size from intensity graph. From that graph, we determine the size of the nanoparticle. And coming to UV visible spectrophotometer, it determines the absorbance peak of nanoparticles. And UV visible spectrophotometer works on the principle of Beer-Lambert. Like if there are larger number of molecules which are capable of absorbing the light, there is a larger absorption of light, and which the larger absorption of light is shown on the peak, that is like absorbance peak of nanoparticles. And the larger absorption shows the wavelength corresponding to the highest absorption is usually referred to as maximum wavelength. From this, we get maximum wavelength and also the absorbance peak of nanoparticles. We get a graph between absorption and wavelength. And coming to know the morphology and also the size of the nanoparticles, we use is a scanning electron microscope. Utilizes focused beam of electrons to obtain the information. Like initially, the primary electron, when it strikes the sample in the vacuum chamber, it produces secondary electrons. Like primary electron striking the sample in the vacuum chamber produces secondary electrons. Here it will be secondary electrons. These secondary electrons are collected by a positively charged electron detector, which in turn gives the 3D image of the sample. From the 3D image like this, we can visually observe what morphology the nanoparticles are having. Either it is spherical or cylindrical or irregular shaped. All the parameters we can get from the 3D image and the size of the nanoparticle also. And coming to transmission electron microscope, it gives a size, shape, morphology, and graphic structure of the nanoparticles. Transmission electron microscope works on the principle like with the sample interacts with the electron beam mostly by diffraction method, and the variation in electron intensity produce information of crystal structure. Like if there is a variation in diffraction of each particle, there is a variation in electron intensity. From there, we get the information about the crystal structure, like graphic structure of the nanoparticles. And coming to atomic force microscope, it gives the complete 3D and 2D profile of the particle. Like we get length, width, and height, and also we get to know the surface topography and roughness of the surface. Like it works on the principle of Hooke's law. Like a sharp probe, it moves on a sample. So if there are any changes in like it senses on the sample, so if there are any changes in the interactions, it is shown on a graph, which from there we can get the roughness and topography of the graph, and also we get the length, width, and height. And from this video we get more clear idea.
Before you can work at the nanoscale, you need to be able to see it. But how do you image something that tiny? The nanoscale is too small to see with the traditional optical microscope, so scientists invented new instruments, like the atomic force microscope. The AFM works by moving an atomically sharp tip across a surface and measuring the interactions between the sample and the tip. There is now an entire suite of scanning probe microscopes that use tips to probe a surface. The interactions are mapped into an image with nanoscale resolution. The maps, or images, can illustrate the topography or roughness of the surface, or other physical or chemical properties enabling scientists to see at this scale. For more on how scientists examine the nanoscale, go to ideastations.org.
And coming to X-ray diffractometer, it gives the phase identification and crystallinity of nanoparticles. It works on the principle of Bragg's law. It is based on the constructive interference of monochromatic X-rays, which gives the crystalline nature of the sample. And coming to the applications of nanotechnology, sir, clarity is there, sir?
Yeah, it's okay, but sometimes we'll get blur. No problem.
Maybe network issues, sir.
Maybe, but in YouTube it is very clear. No problem. You go ahead.
Okay.
So how much time? Probably another 20 minutes, 15-20 minutes.
It's 20 minutes, sir.
Yeah,
15,
fine.
because this application.
Yeah.
And coming to application part of nanotechnology, first we'll go through with the agriculture. Nanotechnology in agriculture have many uses, like it increases the productivity by using nanopesticides and nanofertilizers. Like a plant takes the proper amount of pesticides and proper amount of fertilizers it requires. So in turn, it reduces the amount of fertilizer required and increases the productivity, and also improves the quality of the soil, and it stimulates the plant growth, and provides smart monitoring by using nano sensors and nano chips for identity preservation and tracking. And mainly for nanopesticides and nanofertilizers, nano capsules have been used for efficient use of the fertilizers and pesticides. And in this video, we get more idea.
How will nanotechnology help farmers grow their crops? Farmers need to provide their crops with just the right amount of nutrients, water, and protection. Not enough, and their plants won't thrive. Too much, and excess fertilizers, herbicides, and pesticides are washed away, wasting resources, contaminating the environment, and maybe damaging the crops. Scientists are developing nanotechnology-enabled methods to help farmers produce our food, while saving water and reducing the need for agrochemicals. Nanosensors will monitor individual plants and their environments, enabling intelligent precision agriculture by telling farmers when and where more inputs are needed and when they aren't. Improved nano-delivery approaches also may help plants better absorb nutrients and fight pests. This will let farmers apply less fertilizer and pesticide while maintaining or even improving yield. For more on
Coming to nanotechnology applications more in agriculture, nano-based target delivery approach is used for crop improvement, and nanopesticides can be used for efficient crop protection, and nanosensors and computerized controls are greatly contributing to the precision farming, and nanometers can be used to improve or promote the stress tolerance level, and enhance nanometers can enhance the soil properties or soil. It promotes the healthy soil, and usage of nanofertilizers can improve the germination rate, like yield, growth, and productivity, and it helps in sustainable agriculture. We'll just go through this video.
Does nanotechnology have a place in sustainable agriculture? The answer is yes. This essentially affects all of us ecologically. First, let's shed some light on our terms here. Nanotechnology is essentially science and engineering, but done at a microscopic level, subatomically if you will. Sustainable agriculture can be summed up as an integrated system of plant and animal production practices having a site-specific application, such as farmland. The long-term goal with this is to satisfy human food and fiber needs, enhance environmental quality alongside natural resources, make efficient use of non-renewable resources, and essentially improve the quality of life overall for farmers and the rest of society as a whole. The main reason we want nanotechnology in agriculture, first and foremost, is that it can act as a sensor, predominantly for soils and plants. This allows for monitoring and keeping better track of what we're growing, ultimately allowing us to keep the health of plants and soil in check. Since pesticide and herbicide-resistant plants have been genetically engineered for years and essentially contaminate our food supply, nanotechnologies such as nanofertilizers and nanopesticides aim to increase productivity in crops without contaminating the soil and water supply. Nanofertilizers often provide missing nutrients in plants, which naturally decreases their lifespan and renders them useless. A deficiency of zinc has been noted as one of the most significant contributing factors to the lack of crop productivity. nanopesticides in recent years have also grown. The way nanopesticides are formulated are through encapsulated active ingredients, which are essentially non-toxic and more environmentally friendly. Those active ingredients can also be used to increase pest control effectiveness. So how do we know that these nanopesticides and nanofertilizers are functional or maintainable? Through biosensors. Biosensors contain a biological component as well as an electronic component also found in our nanofertilizers. Since they do contain an electronic component, the signal, combined with a biological component, emits a measurable signal when put through the transducer process, which is just converting one form of energy to another so it becomes readable. The main point here is that it allows for pathogen detection and diagnosis, such as bacterium, viruses, and other microorganisms that can cause disease. Within recent years, this has been used throughout various food industries to measure food quality and safety. Alongside this, nanosensors have been incorporated in food packaging materials to detect oxidation, which is what happens when your food gets stale and goes bad. This was particularly implemented with milk and meat products. So overall, nanotechnology allows us to better monitor what we eat, the toxicity of what we eat, and the safety in which we produce our food. Having sensors to detect potential diseases is a huge benefit for our health as a whole, and not only reduces hazardous contaminants in our crops, but allows for greater and prolonged productivity.
And coming to nanotechnology applications in food science and technology, in different areas of food science and technology, like in processing, it helps in heat and mass transfer area, nanoscale reaction engineering, nanobiotechnology, and molecular synthesis, and in product formulation, either in delivery and the formulation of different kinds of products, and in making food packaging materials, and in food safety and biosecurity by using nanosensors and nanotracers, we know how quality our food is and how fresh our food is, and by using different materials like nanoparticles, nanoemulsions, nanocomposites, and nanostructured materials in various foods and or in various food packaging materials. So these are several applications in food science and technology. And in food, there are like in two forms it can be available, either in nano inside, like by using different additives in nano size and incorporated into the food, or nano outside by making different packaging material like polymer nanocomposites by nano coating, surface biocides, active packaging, intelligent packaging, and bioplastics. And coming to the importance of nano in food packaging, one of the main issue in public health is having foodborne illness, like CDC, Center for Disease Control and Prevention, estimates that impact of foodborne disease in countries like US results in 76 million people are getting sick every year, and out of that 325,000 people are getting hospitalized and 5,000 people are dying every year. So there is an urgent requirement for reducing the foodborne illness by making a different or special packaging material. And in this, we can use either organic material or inorganic material. Organic material like organic acids, enzymes, and polymers may be used for preparing the packaging material, or inorganic material like metal nanoparticles and nanocomposites may be used. First, we will know the importance of nano in food packaging.
Hello, welcome to Food Safety. In this level, we're going to have a look at how nanotechnology might someday be an amazing part of the solution to world hunger. You see, in some places, there just isn't enough food for everyone to eat, while in others, there's more than enough. Scientists have figured out that enough food is harvested around the world each year to feed everyone on the planet. Many countries and organizations are working very hard to help bring the extra food to places where it's needed. The biggest problem is that we lose as much as 25% of that extra food to spoilage and waste. This can happen when food isn't protected well enough or spends too much time traveling to its destination. With nanotechnology, we're already making new packaging, making food safer and preserving nutrition. So maybe we can use it to find ways to protect the extra food from spoiling and make it last much longer. Let's go build a nano and find a way to help.
And knowing the importance of nanocomposites, we'll get to know by this.
Demand for prepackaged, ready-to-serve dishes, sauces and condiments is high. Food is packed hot and prepared at home right in the packaging. Packaging material usually contains a layer of aluminium foil, which protects the contents from its environment. Food may be safely kept in such packages for up to 2 years. When food is packed in film with nanocomposites, its shelf life may be extended. Elimination of aluminium foil means that the packaging can be transparent. The consumer sees what he's buying. Nano-modified packaging is environmentally friendly. In contrast to aluminium-containing materials, these can be recycled. With the use of nanocomposites in packaging, the number of packing layers is reduced. Packaging is thinner and expensive combined materials are eliminated. The quality of the packaging is not compromised. The structure of packaging material, which is formed at the nano level, prohibits penetration of gas and liquid molecules. Nanocomposites are obtained with a mechanochemical process. Polymer and ceramic powders are fine ground, mixed at the micro level and chemically interact. These processes occur simultaneously. A dispersed structure results with nano-sized ceramic particles uniformly distributed throughout the polymers. The new material emerges with new properties. The resulting nanocomposite packaging materials combine the flexibility, elasticity, and processing properties of polymers with the hardness, durability, and heat resistance of ceramics.
Different researchers have found that by using nanocomposites, we can increase the shelf life for more than 2 years for prepackaged foods. And coming to nano-enabled food packaging can be divided into 3 types, like improved packaging, active packaging, and intelligent packaging. Improved packaging is like incorporating polymer or clay nanomaterials into beer bottles or soft drinks and juices. And active packaging is to allow a better protection of food. The packaging material have been incorporated with the different metal nanoparticles like copper, zinc, gold, titanium, and silver. And in intelligent packaging, nanosensors and nanotracers have been used to know the different parameters, like to know the temperature and pathogens, to detect the pathogens, to know the freshness of the product, and it maintains the humidity of the product. And by using different intelligent inks, like the color of the ink changes, like see here, we can see fresh, still fresh, consume immediately. So the color, the ink color have been changed by increase in the life of the food. Like here it is red, and here it is green. Green indicates it is safe to consume, and red indicates it is not safe to consume. And coming to silver nanoparticles based food packaging, it is a form of active food packaging, and it can be either used in non-degradable or biodegradable. Non-degradable like polyethylene, polyvinyl chloride, and ethyl vinyl alcohol. By incorporating all these, we get excellent barrier for packaging. And even silver nanoparticles can be combined with cellulose, starch, and chitosan to form a biodegradable packaging material. And coming to the development of HPMC, hydroxypropyl methyl cellulose, it is a part of my PhD research, and I've developed biodegradable packaging material using silver nanoparticles. I have taken HPMC and I've prepared the solution, and PVA I've prepared the solution. The mixture, like 50% of both the components, I filtered through a muslin cloth, and it casted on a polypropylene plates and dried for about 48 hours. We get HPMC nanocomposite film. And knowing the topic of nano coating on fruits and vegetables, it is mainly used to extend the shelf life of fruits and vegetables to preserve with high freshness. And the edible coating is usually less than 5 nanometer thick, and it is mainly used to control the moisture loss and control exchange of oxygen and carbon dioxide, and to prevent loss of vitamins and minerals, and improve the textural properties of foods. By maintaining every property of food and increasing the shelf life, nano coating has achieved good results in science and technology. And this is part of my work. Like I have dipped the fig fruits in silver nanoparticle solution, and it extends the shelf life of the solution figs for about 6 days. These are like standard silver nanoparticle. These are like biologically synthesized silver nanoparticles, and this is the controlled one. And these are the different microbial population on 6th day of storage. And here we can see how whether like biological synthesized particles are on par with the standard particles. So we can use biosynthesized silver nanoparticles for nano coating. And coming to
Okay, continue.
Applications of nanoparticles in different fields. The nanoparticle has wide range of applications in almost all the fields, like in industrial, electronics, environment, energy, textiles, biomedical, food and agriculture. There are many applications of nanoparticles. And coming to applications in various fields like electronics, it can used in electronic field and sensors. Colorimetric sensor based gold nanoparticles can identify whether the food is suitable for consumption or not, and it is used in catalysis process and diagnosis. To diagnose many diseases, nanoparticles have been used. And coming to the drug delivery, gold nanoparticles have mainly used for detecting the cancerous cell, and gold nanoparticles have usually 600% greater affinity for cancerous cells than for non-cancerous cell. So usually the gold nanoparticles stick to the cancer cell and make them shine, so which they are easy to identify the cell and easy to break the cell. So for that, gold nanoparticles have been used for cancer detection. And coming to the antimicrobial properties, like silver nanoparticles have been used in the socks, paints, kitchenwares, and wound bandages, as they're having high antimicrobial and high antifungal properties. And they're also used as a preservative in cosmetics. And coming to the air disinfection, to reduce the microbial growth in air filters, silver coated filter have been used, and it has shown that there is inhibition of Bacillus subtilis and E. coli within 10 to 60 minutes of using the filter. And in drinking water disinfection, silver nanoparticles have been widely used in drinking water disinfection. Like according to World Health Organization, at least 1 billion people do not have access to safe drinking water. So to prevent this contamination of drinking water, we need some immediate source, like immediate filters, like antibacterial water filter have to be used, which is very safe to use also. So at a flow rate of 0.01 liter per minute, the output count of E. coli observed was 0, but input load is 10 colony forming unit per ml. And coming to nanotechnology changes and nanotechnology solutions, there are many challenges for nanotechnology, like 1.6 billion people do not have the access to electricity, and by the year 2025 we need 50% more electricity. So with these challenges, the solution for nanotechnology is by using nano in electricity, like efficient lighting can be produced, fuel cells and solar cells, and locally distributed power generation can be obtained by using nanotechnology. And coming to supplying clean water globally, as we have discussed, that is 1.1 billion people don't have access to safe water, and by the year 2025 we require 60% more demand for water. So by using inexpensive water purification detection methods, we can reduce the use more water by removing the contaminants. And in agriculture field also, forests being lost annually by about 9.4 hectares, and it is estimated to increase 8.9 billion by the year 2050. So by using different precision farming, using nanosensors, nanopesticides, nanofertilizers, and it increases the high yield of crops by increasing the growth and productivity, and also requiring less water. And coming to information technology, it reduces the cost and increase the performance of memory, display, processors, and solar powered components. And in medicine, there are many new diseases have been encountered. By using nano in medicine, we can get inexpensive and rapid diagnostics, new method of drug delivery, and faster development of new drugs can be achieved. And in healing and preserving the environment, by using nano sensors, reducing the use of harsh clients through the applications of nano coating to surfaces. And coming to future prospects of nanotechnology, nanorobotics is one of the major science in nanotechnology. By using nanorobots in most probably in the medical field, we'll just look into this.
This little bit of rubber that looks almost like a new toy, it's a robot. It's so small, just a little bit over 1/10 of an inch, that it could easily move around inside your body. And it's soft, no sharp edges. What's really impressive, though, is not how small it is, but all the different ways it can move. It crawls, it walks, it rolls, it jumps, it swims, it even climbs out of the pool. The scientists in Germany who worked on the robot were inspired by the movements of living creatures like caterpillars and jellyfish. The robots are filled with magnetic particles that allow the scientists to bend or manipulate them at will.
When we apply any magnetic field, the elastic sheet changes its shape to anything that we want.
Human tests are yet to come, but the robots are intended for medical use, and to do that, they need to do more than just move. The robot can grab an object, or a drug could be added to a built-in pocket. Then a shape change would trigger release. The only thing it doesn't have yet is a name.
When I was presenting this first finding, a few of the audience came to me and said, "This looks really like a Gumby."
What would you call a little wormy, Gumby-like thing that's squirming around your body? In a good way. Gumbo? Gumbino? Or, my favorite, My Little Wormaid. Has a nice ring to it, don't you think?
That is about nanorobots. There are different types of nanorobots and its applications. Like smallest engine ever created is by using nanorobot. The atom is trapped in a cone of electromagnetic energy, and lasers are used to heat it up and cool it down to release targeted drugs or even fight diseases into the body. This smallest engine can be incorporated into the body. And also nano swimmers, polypyrrole nano wire about 15 micrometer long and 200 nanometer thick that can move through the biological fluid like into the bloodstream. It can send at almost 15 micrometer per second. It can move and could be functionalized to deliver drugs and magnetically controlled to swim through the bloodstream to target the cancerous cells. And ant-like nano engine developed a tiny engine capable of force per unit weight nearly 100 times higher than any motor or muscles, called as actuating nano transducers, could lead to nano robots small enough to enter living cells to fight diseases. This is like ant-like nano engine. And sperm-inspired micro robots, which can be controlled by oscillating weak magnetic fields. This is widely used in the medical field. And coming to the nano rockets, constructed a high-speed remote-controlled nanoscale version of a rocket by combining nanoparticles with the biological molecule to develop the rocket to deliver drugs to the target area of the body. These are the different applications of nanorobots. And coming to the future work to be required for nanotechnology, so it requires the public awareness about its advantages and challenges. There are many applications of nanotechnology, but so many people are not aware of it, and it should be there. And the development of new standard and accepted technology for synthesis and characterization of nanoparticles, which is allowed to synthesize identical size of particles. And in biosynthesis, to identify phytochemical compounds which are available in many plant extract, and to increase the laboratory scale production to the large scale production. And need to use their functional mechanism against the pathogenic organisms. And applications of nanosensors and robotics in agriculture and food sector also. And study of nanotoxicity, like how toxic by using nanotechnology, we should know how toxic it is. So the toxic level should be known before using. And by this, I'm going to conclude my presentation. There are many novel applications of nanoparticles in all the fields of science and technology. And we have seen that biosynthesis provides cost-effective and eco-friendly single-step process for synthesis of nanoparticles. And nanotechnology can play an important role in creating safe and more productive agriculture and food system. In food science and technology, a little utilization of nanotechnology can lead to major changes from production to domestic consumption, and it has impact on plants, animals, food science and technology, environmental issues, and in the area of medicine, healthcare. There are many applications of this. So we should better know of this technology, and it is much required to use in further years for better living. So with this, I conclude my presentation, and these are my references I have used. And thank you for giving me this opportunity.
Thank you very much, Dr. Prem Shanti, for wonderful, excellent presentation for covering of brief to and what is the present scenario which we have to focus in the field of nanotechnology. Yeah. So thank you very much. So we have a question answer session, Prem Shanti. So we have a couple of questions has been texted, and most of the questions you already answered, but still, how about migration of chemicals using nanopackaging?
Yes, sir. Like as I have used in my PhD research, I have tested that the migration have been within the nano level. Like there are 0.05 liter, I think, sir. I'm not sure exactly, but the migration is within the limit of the standard, sir.
Okay. So is nano coating is cost effective and also shelf life of can be increased of the fruits and vegetables?
Yes, sir. It can increase the shelf life of food, and as I have worked on it, it increased for about 6 days. And cost also, I think it is costing 1 rupee per kg or 45 paisa per kg, sir. I will just check into it and let you know, sir. But it
Okay.
is very less cost.
Kindly throw some light on the cost effectiveness of nano packaging. Same thing for disinfection application. Does nanotechnology kill spores and microorganisms or develops resistance? For disinfection, so is it going to
Water purification and also?
Yeah, anything, even in disinfection, microorganisms.
Yes, sir. It is widely used for water purification and water disinfectant. Like in many disinfectants, it is used.
Whether they are going to kill the microorganisms which they are developed.
Yes, sir. They're going to kill the microorganism. They're going to destroy that bacteria.
Okay.
So
yeah, there is another same question. When a common disinfectant can reduce the E. coli and the Bacillus subtilis in 10 minutes, then why to go for nanotechnology? Good question. See, if you're using a disinfectant E. coli and Bacillus in 10 minutes, then why you have to go for nanotechnology, which is a costly one? See, it is all time restriction and the cost involvement in the thing. And are there any harmful effect of using nanoparticles in food processing or carcinogenic?
Yes, sir. Consumption, like they have a proper levels for there are different toxic levels. Like if it exceeds that level, there are like bad effects. But better to put within those levels, I think so.
Okay, it is like minimum or maximum residual limit.
Yes.
Yeah. Okay. So how nanotechnology is used for new food formulations or new food development?
New food development, like nano encapsulation, nano capsules have been incorporated into the food. Like if some vitamin or mineral are getting reduced in that proper food by using nano encapsulation and nano.
It's all the required food material and it is all suitable combinations. What are the hurdles come while preparation of nanoparticles in lab?
Main hurdle comes is like to get into the nano size. Like when we are working, is maximum is bottom up approach. So to get into the nano size, that is the major hurdle I have experienced personally.
Okay. The challenge is making the nanomaterials.
Nanomaterials.
Okay. So how many nanotechnologies can be used for functional food development? So it's not like anything can be done. What then is it used in the encapsulation process? Yes, of course, we can use it.
Nano encapsulation has been there, sir.
Yeah, we can do it. Okay, so there is some more questions. Can you bear another 2-3 minutes? So, what cost effective in case of agri fertilizers?
Cost effective in case of agri fertilizers is the amount of fertilizer used is being reduced, sir, because it is a very small level. It goes directly to the plant. Nothing is going to be wasted. Like nothing is going to be leaching out or nothing is going to be carried out by the air. So the less amount of fertilizer is being used. So it is usually cost effective, I think.
Okay, probably there. So when it comes to the green synthesis of nanoparticles, high temperature is used. Is that have any effect in medicinal activity?
In green synthesis, not high temperature is used, sir. Usually it is around less than 100 degrees centigrade. So in chemical and physical, we are using high temperatures.
There will be more temperature generations.
Yes,
how do different methods for formation of nanoparticles affect the size and properties of the nanoparticles?
How? Sorry, sir.
So how do different methods for formation of nanoparticles affect the size and properties of nanoparticles?
It is majorly about this while we are discussing top-down approach and bottom-up approach, sir. By using bottom-up approach, we get the uniform size of particles compared to top-down, and which is labor-intensive. So it depends on the method, sir. Like as we have discussed, green synthesis is getting uniform sized and less sized particles compared to chemical and physical method of synthesis, and also their cost expense. They are expensive.
Okay, is solvent preparation how we get uniform size nanoparticles?
In solvent, then same sir, after doing solvothermal process, the sample we have to take to, like, we have to reduce the size either by ball milling or either evaporating the water. From that we can reduce the size, sir. From there only we can get uniform size.
Okay, why do nanoparticles show high variation in case of antimicrobial activity?
Sir,
so why they are why they are showing in high variation in case of antimicrobial activity?
Because the metal nanoparticles we are using, they are usually or having antimicrobial, antifungal properties, so they are showing major difference compared to normal particles or control one.
Okay, I will take another, because there are so many questions even in YouTube as well as in the Zoom. So probably another 2 questions, very critical questions I will take you. So how nanotechnology help to control coronavirus? Okay. Still the research has to be done in these issues. I may be right.
Yes, sir.
Yeah. So then what are the drawbacks of nanoparticles and its cost effectiveness? And further, why it is not permitted to do in the field experimentation? What happened if it enter the body through respiration in operating person, or by using the labor?
So definitely while working, we should take some precautions like wearing gloves and mask, because it is very small, it can easily enter into the stream. And why it is not permitted to the field experimentation is like, sir, maybe due to lack of awareness and lack of facilities, sir. To go for nano, like to check the size and to check its properties also, we need high-end equipment. So maybe because of those 2 reasons, it is not permitted to do in field experimentation.
No, now in Government of India is already given the guideline. They have made a guideline for conducting the lab as well as the field experimentation with protective measures. The guidelines is already released from the Government of India, but still there is a proper precautions has to be taken care for the field experiment. And how these nanoparticles can be stabilized for a long period? Can you throw for last question?
Usually in industrial and all, they are using stabilizing agents, sir. But when we are using in green synthesis, by stirring, like whenever we are using, we have to stir the particle so that the agglomerated particles can be reduced to nano size. Maybe I don't know, did I answer that? I didn't get proper question, sir.
No, the thing is how you are going
to stabilize the nanoparticles.
Yeah. So only thing is for stabilizations, we have to use a kind of stabilizers, or we have to maintain the pH as well as the temperatures.
pH, and we can stir the material also, sir. Both things can be used to stabilize.
Okay. So there are so many questions, Prem Shanti. So anything, any questions? So please put in a chat box. Definitely, we'll share the chat box to the concerned experts for the clarifications of your doubt, and definitely the answers will get. And the last question, I think, how these nanoparticles help in intelligent packaging?
By nano sensors and nano tracers, sir. We can
for the intelligent packaging, we can save the materials based upon the sensors what they are embedded on the packaging materials.
Packaging material,
yeah. So before concluding, may I request our Dean of the College, Dr. Venugoda, sir. Sir Venugoda, sir. Can you hear me, sir? Okay, probably he might be gone for meeting. Okay, so for there are several questions. Even there are questions from the YouTube also, and even in my personal chat room. Those things will be answered by the Prem Shanti in coming session or coming days. So on behalf of the University of Agricultural Sciences, Raichur, and the Center for Nanotechnology and College of Food Engineering, so we extend a sincere thanks, because so in a short period you have taken care, and especially the appreciated is you put a videos and made the audience or the participants convincing way, because there are participants, even some of the participants may not be knowing the nanotechnology. Some of the participants may be in extraordinary, they are working in the different areas of the nanotechnologies. but you have been balanced the persons who are not aware, and you have been balanced the persons who is working already in the nanotechnologies. So once again, so I take this opportunity to congratulate and also thank you for being with us for in the late night for you. Probably the time maybe it is, am I right?
12:10 a.m. sir.
Oh, 12:10. Sorry for disturbing you guys in this time. Okay, thank you very much for making this morning inaugural session and the first session a wonderful session. So I request Dr. Rupa to say for a vote of thanks to in the morning session. Dr. Rupa, please.
Thank you. Thank you very much, Prem Shanti, for giving a lecture on an overview of nanotechnology and its application. It was really very good information that has been provided by you related to the you have started the lecture right from a brief history and then a timeline of nanotechnology, and then you have covered regarding the different approaches of nanotechnology. Then later you have completed or compiled regarding the synthesis as well as characterization of nanoparticles. Then application, it was really very nice because you have covered so many applications related to agriculture or microbiology related, or ultimately it is the food processing and packaging. It was really informative. Uh, I really thank you for giving a lecture on an overview of nanotechnology and its application. Thank you very much, Prem.
Thank you. And I thank all the dignitaries and organizing secretaries, Sharangoda sir, and co-organizing secretary Uday Kumar Nidwani sir, for giving me this opportunity. And I feel happy to meet you all after almost an year. So thank you so much, sir, for remembering me and giving me this opportunity. Thank you.
Thank you. Take care and be safe. Stay home. That is most important in this pandemic situation. Okay. Once again, thank you very much. Take care. So this is information to all the participants. In the afternoon session, it's going to start sharp at 3 o'clock. We have 2 demonstrations on homogenizer as well as the microsynthesis. So one is Dr. Vivek from BioJed and his colleague is going to give a brief advancement in homogenizer and its applications by BioJed Mumbai. And there is another expert, Dr. Amrish Dave. So he's going to explain about the advancement in microwave synthesis and its applications from Antenpar. So please join with us in the afternoon session at 3 o'clock sharp. There are 2 lectures and scheduled for 1.5 hours, 3 to 4:30. So please be there at 3 o'clock. Thank you very much. Good day. So take care. And sorry for the delay in the starting of the session in the morning. And we took a 15 minutes extra. Thank you very much. Yeah, so you have to join for the same link what we have sent in the morning, and the same link will be there for this day also. Tomorrow the link will be changed. So please join for this link. Thank you. All the best.
Thank you, sir.
Hmm?